You have an Azure subscription with resources listed in a table. The table shows three columns: name, type, and description. Row 1, VWAN1, Azure Virtual WAN, Standard Virtual WAN. Row 2, Hub1, Azure Virtual WAN Hub, Hub for VWAN1. Row 3, VNet1, Virtual Network connected to Hub1. Row 4, VNet2, Virtual Network connected to Hub1. Row 5, VNet3, Virtual Network paired with VNet2. Row 6, NVA1, Virtual Machine hosts a routing appliance deployed to VNet2.
You establish BGP peering between NVA1 and Hub1. You need to implement transit connectivity between VNet1 and VNet3 via Hub1 by using BGP peering. The solution must minimize costs. What should you do? Match these two actions. First, on Hub1, propagate routes from connections to VNet1 and VNet3 to a specific routing configuration. Second, on VNet3, implement a specific routing mechanism.
The available options for both actions are Option All, a custom route table and associate the routes with the default route table. Option B, a custom route table and associate the routes with the same custom route table. Option C, the default route table and associate the routes with the default route table. Option D, Azure Route Server on a dedicated subnet. Option E, Azure VPN Gateway on a dedicated subnet. Option F, user-defined routes.
I believe the correct approach is as follows. On Hub 1, you must propagate routes from connections to VNet1 and VNet2 to a custom route table and associate the routes with that same custom route table. On VNet3, you must implement user-defined routes. This configuration is necessary because transit connectivity via an NVA in a virtual WAN hub requires custom route tables to override the default routing behavior.
By associating these connections with a common custom route table, you ensure that traffic is correctly routed through the BGP-peered NVA. On VNet3, user-defined routes are essential to direct traffic destined for VNet1 back through the NVA, ensuring a valid return path. Other options, like Azure Route Server, are redundant since the virtual WAN hub already provides BGP capabilities, and the default route table lacks the isolation needed for custom transit routing.
User-defined routes are necessary on the local VNet to provide control over traffic exit points in a hub-and-spoke topology. This approach satisfies the requirement for transit connectivity while maintaining the most cost-effective setup by leveraging existing virtual WAN hub features rather than adding unnecessary components. When dealing with complex hub-and-spoke transit, custom route tables are typically the most efficient tool for directing specific traffic flows.